Neural networks in plain English. Make better predictions next time. A neural network is a computer model that is inspired by how human brains work. It's used to recognize patterns and make decisions based on the data it is given. Here's a simple breakdown of how it works and the mathematics involved, explained in plain English. How a neural network works. Input layer. This is where you feed in the data. For example, if the neural network is trying to recognize handwritten digits, the input might be the pixel values of an image of a digit. Hidden layers. These are layers of neurons or nodes that sit between the input and output. They perform computations and pass on their results to the next layer. The more hidden layers and neurons per layer, the more complex patterns the network can learn. Output layer. This is where the final decision or prediction is made. For instance, it might output which digit it thinks was written. Mathematics used in neural networks. Neural networks use fairly simple math operations, mainly addition, multiplication, and a special operation called an activation function. Let's break down these operations. Weighted sum. Each connection between neurons has a weight, which signifies the strength of the connection. For every neuron, it multiplies the inputs it receives by these weights and adds them all together. This is called a weighted sum. Activation function. After calculating the weighted sum, the neuron applies an activation function to this sum. This function helps decide how much signal to pass onto the next layer. Common examples are the sigmoid function, which squashes the input to a range between 0 and 1, and the ReLU function, which passes the input directly if it's positive or outputs 0 if it's negative. Backpropagation. This is a method used to improve the weights of the network. The network guesses an output, checks how far this guess is from the correct answer, and then slightly adjusts the weights to make better predictions next time. This process uses calculus, specifically a technique called the gradient descent, to find out in which direction to change the weights. Learning rate. This is a small number that controls how much the weights are changed during backpropagation. It ensures that the weights are tweaked gently so that the learning process is stable and consistent. Diagram of a simple neural network. Here's a basic diagram of a neural network with one hidden layer. This diagram shows two input neurons connected to three hidden neurons, which are then connected to one output neuron. Each connection's label, like weight 1, represents the weight of that connection. Understanding these basics can be a stepping stone into the more complex architectures and functionalities of neural networks.